Well, I've worked at NASA since 1989. I first started working in the shuttle program, and I worked in environmental controls and life support system. I had an opportunity to do some design engineering work, which kind of led me eventually into environmental work as well. That interested me so much that I went back and got some graduate degrees in that area. And I do research in an area that one doesn't normally think of as part of NASA. I mean, generally everybody associates NASA with things that are up and out, towards space, and all of my research has been down and in fact, down into the groundwater. So if you look back in time, we did a whole bunch of cleanup of parts for enabling space exploration. Back in the 60s and 70s, where there wasn't a lot of regulation telling anybody how to handle those particular types of solvents that we use to do cleanup. And so what happens is a lot of these solvents that we use to clean these parts ended up in the groundwater. But the problem and challenge has been that science hadn't really evolved enough for us to know how to go in and remove or clean up those contaminants that are now in our groundwater. Back in the late 1990s, we had an opportunity to work on a product that we've termed emulsified zero-valent iron, or EZVI. It is an emulsion system that's made up of oil and water and iron and a food-grade surfactant. So all things that are, benign and innocuous to us. And because of the way we make them, they behave very similar to the contaminant. And the contaminants, the chlorinated solvents like trichloroethylene or even Freon, which are a couple ones that we used here, they actually migrate inside that bubble, and when they come inside that oil layer, they actually transport into the inside, and they come into contact with the water and the iron, and breaking it down into something that's not harmful to you or myself or the environment. So my latest technology that we just were awarded the patent on very recently, I think it was last year in 2015, it came out, but it's called SPEARS. It stands for Sorbent Polymer Extraction and Remediation System, and it's kind of got a funny story associated with it. SPEARS is used again for PCB cleanup, polychlorinated biphenyl cleanup, and this technology is really intended to be used in sediment systems. So that's the soil that you walk in right on top that's underneath the water, and that's defined as a sediment system. It's kind of a fun story. I was reading some articles about trash that was washing up on some of the beaches, and the trash they were analyzing for what it contained, and interestingly enough, it had a whole bunch of PCBs on it. So I thought, well, that sounds reasonable. I wonder if we could use that tendency or that hydrophobicity to our advantage, and I wonder if we could enhance it. So I came up to the lab one day, and I stopped by the cafeteria on my way up, and I grabbed a couple of straws, drinking straws. I put ethanol in the straws, and I actually cut them into 2-3 inch sections and heat sealed them using my curling iron, in fact. And so I melted the ends, and I stuck it in a vial inoculated with as much PCB as would dissolve into water, which isn't very high. It's like, 7 parts per million, so close there, it's not a lot. And we left it there, and the next couple of days I came back, and there was actually a cloudiness inside the straw. Oh my goodness, guys! I'm working with a couple chemists in the lab. I said, this could be good. It could either be my straws dissolving or I've got PCBs coming across. But we did take a sample inside the straw and do a mass spec analysis on it, and lo and behold, inside the ethanol there were PCBs. So that was a really infant, small idea, and from that we started engineering how to make it fit on the back of a barge and how to design it so that you could actually install these spikes down to maybe a 2-foot depth. The interesting thing about the SPEARS is having a molecule of PCBs move from a grain of sediment that it's been sitting to for probably 40 years, that it is in a situation it doesn't like at all. Remember I talked about hydrophobicity, how it doesn't like the water it's in, but you got to make it want to go from point A to point B, and you've given it every reason to go. You've given it something it prefers more than the soil itself, and offering it an opportunity to jump across and get to a better spot in terms of a molecular desirement. So I've worked for NASA for over 25 years, and I've done some really cool things and had some amazing opportunities, and some of the best things that I've done is to be able to work with some amazing engineers and scientists. I've had collaboration opportunities that really make all of this possible. I think some of the fun times and some of the most innovative times are on team settings. I recognize and I'm very proud to be part of the Florida Inventors Hall of Fame, but I also want to say that it's such a collaborative experience to go and take a technology from a straw and ethanol concept to a full-scale implementation, and it takes a whole bunch of bright people and bright minds to be part of that, and it's really been my pleasure to work with the people that I have through the years, both in the university setting and as part of my team at NASA Kennedy Space Center.